Hello, welcome back to another Physical Sciences 3 lecture. We have, now we're looking at weight force, so on page 31 of your notes we're looking at the weight force, and weight is something that we often use in an incorrect kind of way. So weight force is measured in newtons, but what we often think of as our weight is actually mass. So mass is measured in kilograms. Okay. So when you jump on your scale, you're actually measuring your mass and not your weight. Okay, so it's one of the things that we often have a misconception about. So for example, if you went to the moon in a rocket, if you went to the moon, your weight force would be less, but your mass would still be the same. Okay, so your mass, whatever you measure yourself to, be in kilograms will be the same on the moon, but the weight force that you experience will be less. So that kind of brings us to saying what the weight force actually is. The weight is dependent on the gravitational field of, say, like if we're on Earth, then it's dependent on that that gravitational force. But if on the moon, the gravitational force would be smaller, and so your weight would be smaller. And we have this equation here. Force is the gravitational force, Fg, is equal to the mass of an object times by the gravitational force. And just remember that on Earth, G equals 9.81 meters per second squared. Okay, so that's an acceleration. Okay, we just have a couple of alternative ways that you might see alternative representation of the weight force. You might see these in textbooks or in other examples. Fw, sometimes that's the weight force, and just W. Sometimes people call that the weight force is W. So weight is a force, so it means it's a vector and its direction will be downwards towards the center of the Earth. Okay, because it is a force, the unit of weight is in newtons, like I've just said before. And again, just reiterating, it is important to remember that what we refer to as weight in everyday life is actually mass and has units of kilograms. So that's what I was kind of talking about just now. So let's have a few examples where we're actually calculating the weight force. So what is the weight of a 65 kilogram student? So F equals mass times the gravitational acceleration. So it's equal to 65 times by 9.81, and that is equal to 638 newtons. Okay. Calculate the mass of an object which has a weight of 4.9 newtons downwards. So, okay, so this time we know our Fg. So this one is Fg. So we want to calculate the mass. So the gravitational constant, we're still on Earth. So we've got 4.9 equals mass times 9.81. So m is equal to 4.9 divided by 9.81, and that's going to be roughly 0.5 kilograms. Okay, so these formulas always give mass out in kilograms. Alright, so weight force always acts on a body regardless of its position or motion unless we move a large distance from the surface of the Earth. It is constant. So unless we're up in a spaceship or on a space station or something like that, it's going to be constant. Okay. Next we'll talk about the normal force.